Hi, Year 9. So in today's lesson, we're going to talk about how computers use algorithms to sort and search for data. In today's lesson, we're actually going to talk about how a computer uses a set of instructions to search for data. In last week's lesson, we talked about how computers or anybody, can use computational thinking, abstraction, decomposition, and algorithmic thinking to solve problems. Today, we're going to talk about how a computer is solving a problem of searching for something using a linear search and a binary search. And next week, we'll start talking about sorting algorithms too. But think about searching for things on a computer. I mean, it happens all the time. Whether you're searching a web browser like Google, or whether you're the doctors and they're searching for patients' notes, or a police officer who can search a vehicle identification number to find the owner. All of those kind of things are just where there's a whole bunch of data, and well, you need to find just one thing from it. A lot of times when you're looking at data on a computer, it will be sorted in a certain way, whether it's alphabetically, numerically, or chronologically. There'll be some kind of sorting mechanism. We're going to talk about that in more detail next week, but know that most of the time when you're looking at data, it will be sorted. So let's suppose that we've got a dictionary and we're trying to look up the word nebula, right? What is your strategy? Well, you could, if you wanted to, start at page number 1 and figure out if nebula is there or not, and then go to page number 2 and figure out if nebula is there or not. Or this is what most people do: just open up in the middle somewhere and then figure out where you need to go from there. That is called the binary search. Now, a binary search is where we get a list of items, so it doesn't matter whether they're numbers, dates, or like in this occasion, names, but they've got to be in order, right? They've got to be in alphabetical order for it to ever work. The quickest way we can find a particular name in a sorted list is to perform a binary search. Let's say that we're searching for the name Mo in this list. The list has 11 items, and the first thing we need to do is find the middle one first. In this list, the middle item is Lara. Lara comes before Mo alphabetically, so what we can do is actually discard all the names from Ali to Lara. Now, we only have 5 names to search. Notice how this is really similar to the guessing game that we did last week. If we're halving the list every time we search for something, we're going to get to the thing that we're searching for just a lot quicker. So we've gone from a list of 11 names to now just 5. And we just start the process again. We look at the middle item, which is of course Pam, and we know that Mo comes before Pam alphabetically, so we can delete everything from Pam onwards. The next thing we do is, well, we've got a list of 2 names on this occasion, right? And the reason we look at Mo is when we've got an even number of items in a list, we always go left of middle. That is just a convention that we would always use. If there's no actual middle there, we would always, always, always go left of middle, regardless of the situation. On this occasion, thankfully, left of middle is Mo, and we found the item that we were looking for. So how many did we look at? Well, we looked at Lara first, then we looked at Pam, then we looked at Mo. So in 3 searches, well, we've managed to find what we were looking for. In actual fact, though, we don't need to know what's in those boxes. We don't need to know the data within it. All we need to know is that it's in order of some kind. I'm going to tell you that in all of these boxes from 1 to 16, we've got numbers. Numbers in order. Potentially that first number could be 0 and that 16th number could be 3 billion, right? But as long as you know that everything from 2 to 15 goes up in order, right? Suppose we're looking for the number 23 in this list. So we've got 16 items. The first thing we need to do is look in the middle box. So we need to figure out what that middle box is first, right? In this occasion, it's the number 8 that we've got 7 on this side, and we've got, well, a little bit more 1, 2, 3, 4, 5, 6, 7, 8 on this side. So there wasn't an actual middle because we had 16 items. But remember the convention, we always go to the left. So when we open this box, we've got the number 42. Well, if we're looking for the number 23, we can delete 42 to the end there because we know that if it's written in numerical order, then 23 has got to be on this side somewhere. The next middle we'll look at is 35. Well, we know that 23 is less than 35, so again, we can delete everything from 35 onwards, and then we're left with 3 boxes there. Next one is 27 in position number 2, and we know that 23 is below that, so we can delete everything there. So in box number 1 is the number 23. There we go. So how many numbers did we look at? Well, we looked at box 8, where there was 42, box 4, where there was 35, box 2, where there was 27, and then box 1, when there was 23. So we looked at 4 items overall. There we go. But let's say that we were using the other search, something called a linear search. Now, a linear search is where the data set doesn't have to be in any particular order. It doesn't have to be alphabetical, doesn't have to be numerical, doesn't have to be chronological. It can be in any order. If the list to be searched is not sorted, it is not possible to do a binary search. We just can't do it. Because if we look at the middle item and go, well, we're looking for the number, I don't know, 27. Well, we know that 27, well, should go that way. Oh, well, it does on that occasion. But what if we were looking for the number 91? Well, we'd think the 91 would be on that side, but it's not. It's on this side. The fact is that it has to be in order for a binary search to work. A linear search, however, is where it doesn't need to be. This is where items are examined in sequence, one after another. So if we're doing this, we would literally, if we're looking for the number 777, for example, we look at the first item and go, is that 777? Well, it's not. Is it that one? No, it's not. Is it that one? No, it's not. Is it that one? Oh, yeah, it is. There you go. So quite literally, a linear search is where you look at each item in order as you go up the list, one item at a time. That is the silly way of looking for anything, but it works if it's not in order. Even if we had a million items, if we used a binary search and they were all in order, it would actually only take a maximum of 20 searches to find anything in there. That's it. If we used a linear search, well, it would take a million, wouldn't it? That's way more than 20. That's why the binary search is just always better.